Hello, I'm excited to be here. I'm Liana. The next 25 minutes are about scary data stories I faced with during my career. And I promise most of them are going to end up happily. So I've been solving data issues for over 20 years. And today I want to share with you some traps I fell into while solving data issues, while being an entrepreneur, and also solving data challenges with my clients. So for each of the 4 stories, we're going to start with the business issue, then we will go to the underlying architectural problem, and after I will describe the solution we came up with. So hopefully by the end of this session, you have some more creative and effective ways to handle your data issues. I personally believe that minor accurate changes can do a great change. I know that from my experience. And unless more drastic changes are unavoidable, like data migration and production code changes, I always prefer this first. It doesn't work. Okay. So once upon a time, I founded a startup. And we had this initial product and an opportunity, exciting opportunity, to have a grant of $50,000 in exchange for a POC with specific IoT company. So we started collecting all their data 24/7, real and not so real IoT data. Honestly, at the beginning, I didn't even know what I'm going to provide and which metrics. And so, blinded by this opportunity, I just gave them the flu dust with buckets of data without even knowing if it's necessary. And the thing is that even after this successful POC, we gave them this ability to junk us with their data, despite knowing by them what is actually necessary and what is not. And this kind of issue I meet it in many companies, many organizations all the time, in the past, during my career, and today at TeraSky. So whoever is not familiar with TeraSky, TeraSky is global solution integrator specializing in data and DevOps. I joined TeraSky recently, and actually because I met some people that share my addiction to constant problem solving. So back to my story. As we are in a Halloween spirit, I want to raise some demons from their graves. And the first demon we have today is our vampire of slow queries. Back then, with all the data I had collected, I couldn't retrieve anything, absolutely nothing, fast enough when it was the time to present to investors. And you know, investors are not the most patient people. So once I was trying actually to understand why my queries are so slow, I was facing this underlying problem with the zombie of data. Actually slowing down behind the scenes our processing and our queries, because it was scanning all the data we stored forever. And this happened because we stored every information we collected non-selectively. Now, as business grows, and scales, data issues tend to grow exponentially, often exceeding the revenue they actually generate. It's an issue that even many successful companies face. And I want to show you an example how you can still get control over your costs on database and keep it in line. So, excuse me. So suppose, let's imagine we have a relational database and this huge table that gets requests from two sources. From application code that running the low latency queries and the ad hoc analytics run by the team, less sensitive to latency. And if we go through all the queries and the history query, we can find that there are clear three groups of queries. We have, sorry, queries that run on the last month data. We have queries that run on last 6 months data, and the small portion of data that run only by the analytics team that uses actually all the history. Now, before we go on to the solution itself, some background. You're probably familiar with products that manage for us the data lifecycle, like storage products like S3 and data warehouse products like BigQuery. They do that before. They do this because they want. So we won't pay actually for data that we do not use, and this is great. But we can do it even better if we customize it to our specific solution. And what we need for that is actually our database aided with orchestration tool like Airflow. This was my choice. And the minor change, if you remember, that I spoke about in the second slide, is what we are going to do. We're going to take this huge table and split it into two tables. Small table of last month data and all the rest of the data. Now, on top of that, we put a view. So if we want to hit all the history, we are able to do so. Now, in this architecture, actually, our critical 80% application code run on a smaller table, massively improving our performance. What Airflow does for us is actually it sustains this state of our database over time and continues moving the data from last month data to other. Now, we can do it even better. So to do it better, we actually take this all the rest table information and split it again. But this time, we don't put the information inside our database. It's a virtual table, a type of federation. The data is actually stored in any kind of HDFS, cloud storage you wish to have, S3, GCS, Azure Blob Storage. And now, if you have, for example, a Redshift cluster, you do not need to increase its size just because you store outdated data inside it. You will increase its size if you actually need additional processing. Again, Airflow moves the data for us in this use case again, as it did before. Now, in this architecture, we're actually keeping, we have control over the prices of our database and keeping it in line with our business. Now, if we want to create that kind of data federation, you can find several products, many actually products in the market. Even if you have a single cloud architecture or you are working with on-prem, but the standout products and solutions here from the architectural point of view are Trino and Starburst, because they actually do federation by definition. They don't have its own storage. They have only the additional processing they do on top of your already existing databases. And it's not my habit to advocate for a specific product. I just trying to explain that these products can create a totally different architecture. And just like that, we got rid of our two demons. So to the next story. This company almost vanished because of the high data cost they had. And okay, so it was an IoT company, and they were running data on their BigQuery, and it was just not adjusted. All the data channel SLAM wasn't adjusted to their usage. But among all the things they had in their data channel, I want to speak specifically about the BigQuery, because they had their 6-digit billing number monthly. It was the most expensive product in their monthly invoice, and it was the heart of their data. So they actually ran with this BigQuery into inefficiency because they didn't use it in the right way. So here we have, with cost, a bunch of demons, because data cost has many issues. And every product you can find in the market can cause you inefficiency, not because of the product itself, but because we actually do not leverage the specific abilities of the tool we are using, and not adjusting the metadata to our actual usage. But the thing is that it's most common with pay-as-you-go billing models, because they tend to tell us that we can avoid overspending, but more often than not, we pay much more. Now, before I go on to the next slide, I'm just telling that this solution we are going to show here is right for every database, data warehouse, data lakes, whatever data stored with processing you have there. So let's go to the first part of the solution. The solution is always in two parts. The first part is leveraging the specific capabilities of our tool. In this case, we have the BigQuery, and this IoT company having the high-frequency data stored multiple timestamp columns and updated, sometimes updated, and everything was to deliver actually time series metrics. Now, we simplified everything by removing part of the code and just adjusting everything, just using the right BigQuery functions. Those functions, part of them actually store the timestamp for you behind the scenes. You can use it. Also, you can find other functions that pre-aggregate for you the data. So once you run on-demand metrics, you can run it more efficiently as you scan significantly less information. Now, remember this example, because later we will have an example that does the opposite, because actually I'm going to say that it's wrong to store metrics in advance, and so keep it in mind. Now, the second part of this solution is actually adjusting metadata. And here I have a simple example. Actually, initially, because of the nature of this company and data series and time series data, they partitioned everything by timestamp. But eventually, as they grew, they were using additional fields. And how we can find it, we can see on the query history. It's the most reliable way actually to understand what the business needs. So I took here a simple example when we are using also, for example, region and status in our queries. And we want to make those queries more efficient and cost efficient. So what we do here, we are repartitioning by region and splitting the table by status. Now, it's important to understand when we do repartition and when we split. For me, splitting is kind of more aggressive repartition, but actually, it's ideal when you have data in a table with in different stages of its life cycle. So, for example, in our case, inactive data that's soon going to be outdated shouldn't be stored in the same table with data that is actually live. A last thing about cost with data, the FinOps tools existing today in the market are not actually provide us tool to manage and reduce costs. Because, for example, if you have, again, a Redshift cluster and you have 20 tables you didn't use for the last year, you can see it in any FinOps tool, at least those I know. And the way today to to manage our cost is actually by avoiding cost. And avoiding cost done by database management and maintenance, as we showed before, adjusting the metadata, as we did in this example, and knowing the exact products and their capabilities when we use them, and taking advantage of this. So yes, and this example showed us not so trivial change and not so small change, but it was unavoidable in this specific use case because we couldn't reach lower costs if we wouldn't do those adjustments. To the next story, actually, this company had painfully slow onboarding times. And if it's not enough, they also had a drop of almost 40% of their clients dropped off during the onboarding process. And it was just frustrating. So in this use case, it wasn't just that the onboarding took days. The thing was that there was inconsistency in data, many errors, and it's all because each piece of information went through many stations till they got to the final BI to their clients. They had several NoSQLs, several SQLs, warehouse, another replica for warehouse, until it was reaching and connected to the BI. And multiple pipelines and ETLs running from one to another, which is not so fault tolerant. And in this use case, what's important actually to understand, I want to show you an example how we solve it. Another issue actually we had, I forgot to say, another issue we had in this use case that they were using, I will return. They were using a database, data warehouse actually, that didn't fit their need. They had to parse multiple JSON files in memory on demand, unfortunately, and it was just not able to do so. So this is the reason they had so many databases in between and so many stations. And at the end, what happened is that clients were, keeping and filling in tickets saying, okay, the data and the BI that we see doesn't fit actually our data as we see it. And they expected more reliable and real-time dashboards. So to deliver so, we first had to replace the data warehouse and to choose one that actually separates storage and processing, making it scalable in each part separately, and able to process JSON data in memory. Now, we again aided with our Airflow orchestration tool. You can choose your orchestration tool as whatever you prefer. And what happened here is at the minute data came into the data warehouse, there was a trigger in Airflow that parsed all the data to metadata, creating actually what tables should be created for this data. It was joined with all the metadata actually already existing in the database, and with the simple string aggregate that actually exists in every database, you can generate long string of DDL operations you need to run. So it gives you some list of DBA tasks, tables you need to create or alter, and then it goes back to Airflow and triggers the operations of create a tree of tasks for me with all the DDLs I have created before. And once it creates the tree, it runs all the tasks with predecessors, one after another, cleans the history after, cleans all the tree, publish the data to the BI, and in 10 minutes we have data that ingested to data warehouse and provided to clients with real-time BI. Now, and so easily we got rid of another 2 ghosts by just automating our DBA operations. Now, the last but not the least, but my favorite, an airline company that had Spark operations running on a daily basis. They had actually to define the pricing for each flight on a daily basis and update on their website. But unfortunately, even though they had almost 50 huge processing instances on their Spark cluster, the cluster would fail, the process would fail every other day. So it wasn't just expensive, it was unreliable. In this use case, actually, what was the problem? Reading multiple thousands of Spark code and telling where is the problem? What makes Spark reach its limits? And back then, I was running my professional service company, and I really wanted to gain this client, and had several days actually to detect and to tell them where is the problem in their Spark process. So what we did actually this diagram, but it wasn't enough because it didn't give us the critical piece, which is what is the size of the data frame that causes this fail of Spark. So we asked for more information, a sample data set, plug in the number. We actually estimated the size of the data set in each step. And then we could put our finger on the bottleneck and say where exactly the problem is actually happening. After debugging, we also confirmed it. And we knew that the next step is actually rechanging the order of operations, so we could reach to this exact point with less in-memory processing. This example is only one of them. It looks an easy one to understand when it's on diagram, but very hard one to detect when you are reading thousands of Spark code. And they had multiple of this kind and other kinds. So you can see that with reordering, by simply reordering the operations, you can reach to the same result with less in-memory processing, less distributed processing. And even their cluster, not only that it was stable, it costed them 30% less. So you can see that with a bit of creativity and visualization of your distributed processing, you can, first of all, find errors in your existing code. And second, if you build one tomorrow, and I suggest you first to create this data flow, to estimate, plug in the numbers, to put the numbers, what is the size of each data set that's going to be created in memory, and only then writing the code itself. So that was the last story, and I hope you got some ideas on how you can tackle your data issues. You can do automation for DBA. You can do automation to squeeze your processes to deliver real-time BI, to keep your databases lean, manage costs by choosing the right product in the right way, and managing its metadata. And finally, you can, with a bit of creativity, do much better distributed processing. Now, if I believe that in the future, all the things that I did here are going to be done with AI. I totally see how it can happen. And if you are interested in these kind of things, you can also reach out to Elad, my colleague. He was presenting in the DevOps Days in Boston last week. So the last thing, the last advice I would give you is actually to keep it simple, know your product, manage, gain control, and don't rush to fancy solutions. Each business is unique when you are speaking in with data, in terms of data. And that's it, I think. Last thing, if you want to know actually what tools to choose and what architecture to create, it's best to look at your existing usage, your queries running on top of all your data. Most information there will be enough to make the right decisions. Thank you.